Welcome to True Projects. In this video, we are going to explain about the project that is Ensemble learning based approach for email spam detection. So before getting into the execution, first let us understand what is this project about. So basically, emails have become the main way people communicate today. Not just for casual stuff, but also for work, banking, shopping, and official conversations. It is super fast, cheap, and also you can send it anywhere in the world instantly. That's why billions of emails are exchanged every single day. But here the problem is with huge growth in email use. With this huge growth in email use, spam emails have exploded too. And spam isn't just those annoying promotional messages. Many of them are actually dangerous. A big portion of cyber attacks start through spam because attackers use it for phishing, spreading malware, stealing the data, or tricking people into fraud. The bad part is spam. It wastes a lot of time and resources. It fills up in boxes, eats up storage, and even slows down email systems. On top of that, if spam slips through filters, it can put both individuals and also organizations at serious risk. So while email is super useful, spam has turned it into a big security and productivity challenge. So here, to deal with the problem, of spam, researchers started using machine learning, which basically means teaching computers to recognize spam emails automatically. These systems look for patterns in email content like certain words, links, or other clues and use that to filter spam without a person having to check every message. So here, some people, that is some popular methods like support vector machine, naive Bayes, and decision trees work pretty well in some cases. But the problem is, spam keeps changing. Spammers are always coming up with new tricks, so these traditional methods sometimes get it wrong. They might mark a real email as spam or worse, let a harmful spam email slip through. So, this shows why we need a smarter, more flexible spam detection systems. Ones that can adapt to new spam patterns, catch most spam accurately, and avoid flagging legitimate emails. In short, the goal is to make email safer and easier for users without wasting their time. So to overcome from all such issues in this project, instead of relying on just one single model to detect spam, we are using an ensemble model. So here we are using ensemble model, which basically means we combine several models together. The idea is simple. Each model has its own strengths and weaknesses. But when you put them together, they can make better predictions than any one of them alone. So this approach it helps the system to catch spams more accurately and also deal with new types of spam that it hasn't seen before. Because spammers keep changing their tactics. A single model might miss some of the clever ones, but the ensemble can adapt better and give more reliable results. So in this project, we are using different types of models to detect spam. One is support vector classifier, which we call it as SVC, multi-layer perceptron, that is MLP, and extra tree classifier. Each of these models looks at the emails in a slightly different way and makes its own predictions about whether email is spam or not. To get the most accurate result, we don't just rely on one model. We combine their predictions using method called voting and stacking. So think of it like asking three experts for their opinions and then making a decision based on all their advice. So here, the system doesn't just make spam detection more accurate, it is also built to handle new and tricky types of spam that keeps popping up. Because it combines different models, it is more robust, meaning it can adapt to changing spam strategies without breaking down. So furthermore, to improve the performance of this project, here as an extension, we are using, that is, we are combining different models to make voting and stacking classifier. So previously, we combined support vector classifier, multi-layer perceptron, and extra-tree classifier in voting and stacking, right? So here, as an extension, we will be developing same voting and stacking classifier, but by combining different models. So here we are combining ADA boost, XGBoost, CAT boost, and Light GBM. So we are combining these models in the voting and stacking classifier as an extension. So the idea here is that Each of these models has its own way of spotting patterns in emails. So by combining them, the system can handle more complex spam emails and make smarter, more reliable predictions than using just the basic model alone. And here we have also added XAI technique, which is SHAP, to help the system to understand how the model is making its decisions. Basically, SHAP shows which parts of the email, like certain words or features, are influencing whether the system thinks it spam or not. And this is really helpful because it makes the system transparent. Instead of just giving whether a email is spam or not spam, we can see why the model made that decision. It makes predictions more trustworthy, especially when dealing with tricky parts, that is, tricky or important emails, where understanding the reason behind the classification matters. And furthermore, here we have developed a user interface, simple web interface by using Flask. We have developed a web application so that people can actually use the system, and the app has user authentication too, which means only authorized users can log in and use it securely. Once logged in, a users can simply paste or type in an email and the system will run it through the trained models in the background. It can automatically does all the pre-processing and classification, then instantly tell us the user whether the email is spam or not spam. So this is the extension part. Now moving on to the implementation. To implement this project, here we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented. First, we have implemented all the necessary Python libraries, packages required for data handling, pre-processing, machine learning, and deployment. Then comes data ingestion. So at this stage, we collect the email dataset from Kaggle, load the dataset into Pandas data frame so that it can be easily processed and analyzed. Coming to data processing, so here at the stage before encoding, that is before training the models, we perform encoding and clean the data set to remove unwanted characters or the missing values. And we will be applying tokenization to split the text into words, remove stop words, and also apply stemming to reduce words to their root forms. And we will be converting the text data into numerical features using TF-IDF factorization, which allows model to understand the performance, that is the importance of the word. And we handle imbalance using smooth oversampling, ensuring that spam and non-spam emails are represented fairly. After that, we split the data into training and testing sets so the models can learn from portion of the data and be evaluated on the unseen data. Then we train multiple classifiers on the training data, including base models and the ensemble models, to learn patterns that differentiate spam from non-spam emails. And we will be evaluating all of them on the unseen dataset to check how well they perform. And we evaluate their performance using metrics called accuracy, precision, recall, and FN score, and also confusion matrix to identify the false positives and negatives. And we also use explainable AI model, that is to understand why the model is making certain predictions. And we will be saving best performing model for the future use. Then coming to the part of front end, here we have created a simple interface where users can input email text, and we will be loading the save model in the backend. It will be pre-processing. I mean, the given input, it will be pre-processed. Then it will be fed to the train model, and the train model will be predicting, and the result is shown on the front end. So this is how we have implemented. Now moving on to the algorithms used. These are the individual models that we have used: decision tree, naive Bayes, random forest, multi-layer, that is extra tree classifier, multi-layer perceptron, support vector classifier. And all these are combined individually in the voting classifier as well as stacking classifier. Coming to extension models, so we have used same voting and stacking classifier, but we have combined with a different combination. So in voting classifier, we have combined these models, and in the stacking classifier, we have combined these models. And to implement this project, basically we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, let's open the code folder that contains source code files. So let's open it. So these are the source code files of this project. Let's understand each of them. Here, this is the model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases that we will be using in the front end. And here we have app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have dataset that we have used in this project. Let's open it. So here we have the dataset, and this is the target column that we will be predicting. And here we have messages. So we will be training the models on this data itself. We'll be training on this data. Now close it. So here we have Jupyter Notebook file. It contains a combination of code, graphs, and outputs all in one place, and it allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the database file which is used to store the user information. So this is all about the code folder. Now let's execute it. So copy the path of the code folder from the address bar of the file explorer. So I'm copying it. Now open Anaconda prompt. So it is opening. So now give the command cd, give the space, paste the copied path and click on enter. Here you can observe current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flash Framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So just wait for a while. File is being compiled. So this is the address where application has been hosted. So copy this link provided by the Flash framework and paste it into any web browser. I'm copying it. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flash framework. So we need to get signed up first. So click on sign up and create an account if you have not created, and fill in all these details to create an account. I have already created, so I'll directly sign in. Click on sign in. Provide your username and the password. Click on sign in. We have signed in successfully and redirected to this prediction page of the project. So let's do prediction. Click on predict. Here you can see a text box, right? Here we are supposed to give the input to check whether an email is spam or not spam. So let's open test cases for that. So here we have test cases in the sample file. So this we will be not giving. We will be giving these messages and we'll be predicting whether email is spam or not. So let's check with this one. Copy it, get back to the application, paste it. Now click on predict. So this given input, it will be pre-processed at the backend. It will be fed to the train model and the train model will be giving us a prediction. So here you can see we got prediction to be not spam. And this email is safe. So our AI model predicts that this model is not spam. You can safely open and read the message. And these are the recommendations. So here it is recommending that always verify the sender if you are unsure. Be cautious with links and attachments, even if it is safe mail. Keep your email software up to date. So it is giving all these recommendations. Now let's check again. Click on check again. Let's try with this message. Get back, paste it, and click on predict. So here also you can see a safe mail has been predicted. Now let's check with the other one. So let's check with this one. Get back, paste it, and click on predict. Here you can see spam email has been predicted. So here you can see warning spam detected. Our AI model that is our AI model predicts that it is spam email. And please do not click on any links or download the attachments from this message. And here it is recommending that do not respond to suspicious emails. Mark the email as spam in your email client and delete the email if you are certain it is unwanted. So let's check with one more. Let's check with this one. Get back, paste it, and click on predict. So here you can see it is predicting it as spam email. Let's check with one more. So let's check with this one. Paste it, predicted. So you can see spam has been detected. In this way, you need to do the prediction. Let's check with the graphs now. Click on graph. So here the first graph which we have is the sample outcome graph. Here on x-axis we have the classes that we are predicting, and on y-axis we have count of each class. So close it. And here we have total spam words. That is word cloud it is. It is correlation. I mean, this is confusion matrix. Close it. And here we have model accuracy. So here on x-axis we have the all algorithms name, and on y-axis we have accuracy. And here we have precision score comparison graph. Here we have model recall score. Here we have model FN score. So these are the four metrics used to evaluate the model. Now click on sign out. So this project, it helps us to make email safer and more efficient by automatically identifying unwanted messages, saving user time, and also protecting them from potential threats, making digital communication smoother and more secure. So just by giving email to the application will be predicting whether that email is spam or not. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.